All right, I'm going to be going over the Chapter 3 review problems. Consider, I suppose, this kind of the answer key. 3.1, 3.2, angles formed by parallel lines. These are a bunch of vocabulary terms that we need to know from this section. So parallel lines, we'll need to know what that means. Transversal, corresponding angles, alternate interior angles, alternate exterior angles, same side interior angles. Those are kind of the new terms and things that we discussed in this chapter, so you'll want to make sure you know those definitions. Um, when we have parallel lines that are intersected by a transversal, so you can see in the pictures there, but if I draw another sketch, we have one line, another line, and they are intersected by a transversal. Doesn't matter the angle that that comes at, could be like this, could be over here, could be perpendicular, doesn't really matter. Wherever that transversal is, we create some sets of congruent angles and some sets of supplementary angles. And so we give those names, and there's some theorems associated with it. So corresponding angles are, I'd say, angles that are in the same position. So we could have like this angle here and here. In this grouping of four angles and in this grouping of four angles, these are in the same position. If you kind of think about it, they're in the upper left position. And this postulate states that those have to be congruent to one another. Then we have alternate interior angles. So this is our interior space in between the parallel lines. Alternate interior angles are angles that are on different sides of the transversal. That's the alternate piece. And then interior, they're between the lines. So these two angles would be alternate interior. Or these angles here could also be alternate interior. Those angles are going to be congruent when we have parallel lines. Then we have alternate exterior angles. So the exterior is outside of our parallel line. So this space here and this space here. Alternate exterior angles are very similar. They're on different sides of the transversal in the exterior. So something like here and here. This theorem says that those angles are going to be congruent. These angles here would also be congruent and alternate exterior as well. Our last theorem is about same side interior angles. So same side refers to the transversal interior, the interior space. So these angles here are same side interior. The relationship for this one is that they are supplementary, that they are going to add to be 180. Or these angles here, also same side interior, also going to be supplementary. You can see in the picture down there. All right, so some other things we need to know from this that we will use here and there are vertical angles. When we have two lines that intersect, the lines that are directly across, the angles that are directly across from each other, the ones that are not next to each other are considered vertical angles. And we had a theorem from chapter 2 that stated those angles are congruent. So 1 and 3 or 2 and 4. In fact, I can make some markings here. That angle 1 and angle 3 would be congruent. And then angles 2 and 4 would be congruent to one another. Those are vertical. We make use of that whenever we can. It's a pretty easy property. The next thing we have are linear pairs. Linear pairs we did a lot of work with in the last chapter. They are two angles that form a line together. Right here, 1 and 2 is an example. 2 and 3 is an example. 3 and 4 would be an example. 1 and 4. Lots of linear pairs here when we have lines that intersect. They're supplementary. They add up to 180 because they make a straight line. We're going to make use of that when we can. All right, so let's go ahead and name these angles. So we're talking about those different angle relationships that we had. Angle 2 and angle 6. So I'm going to highlight those real quick just to 2, 6. They connect one grouping of angles to another grouping of angles. So they're one of those new vocabulary terms. They're in the same position, so we call these corresponding. I'm going to abbreviate these sometimes. Corresponding angles. Then we have 2 and 7. So let me erase some of the markings here. 2 and, oh, I'm sorry, not 2 and 7, 1 and 7. So 1 is here, 7 is here. These are both in the exterior space, right? Outside of the parallel lines. Parallel lines are here. And they're on different sides of the transversal, so we call those alternate exterior angles. These would be congruent, so with these. Just reminding the theorems and postulates that go with these different things. Okay, moving forward, we'll go a touch faster. 3 and 5. 3, 5. Those are both in the interior and they're on different sides of the transversal, so we call those alternate because they're on different sides. Interior angles. These would also be congruent. 4 and 8, 4 and 8. One's in the interior, one's in the exterior. They're on the same side. Okay, these are in the same position. They're both in the lower right position. If we moved this grouping of angles over here, they would line up exactly on top of each other. So we call these corresponding angles again. I'm going to abbreviate that. Corresponding angles. Again, congruent in this case. 3 and 6. So here we have 3 and 6. These are both interior and they're on the same side of the transversal. So same side interior. These ones are going to be supplementary. Remember, this is the different relationship, supplementary. And then our last one here, 2 and 8. 2, 8, alternate exterior. Alternate exterior angles are congruent. We didn't have any examples of vertical angles or linear pairs here, but they are worth noting. So just let's say we were talking about 1 and 3. Those would be considered vertical angles and thus congruent. A linear pair might be something like 4, 5 and 8. Those could be a linear pair. We want to make use of these relationships when we can. If we know one of these angles, we can kind of make use of it to figure out the rest of them. All right. Next, let's do this one. All right, so we start off with one angle measurement that we know, and we have some parallel lines. So the measure of angle 13 is 102 degrees. Now, we could just go ahead and just fire off only the ones we know, or we could try to figure out all of them. It just doesn't really matter. I'm just going to go in the order that they're here. So angle 10 is going to be vertical with 13. Those are vertical angles, so these would also be 102. 15, all right, so angle 15, these are same side interior angles. So these are going to be supplementary. 13 plus 15 is going to equal 180. So I need to figure out what would add up to 180 with 102. That needs to be 78 degrees. I could do a little quick subtraction for that and get, 78. So that's what we get there. I'm going to label that in case I want to make use of it. Number 14, angle 14. So that's going to be alternate interior to 102. So those would be the same. Go ahead and label that one too. I could have also done that it's corresponding to 10. Those are in the same position. Or I could have done that it was linear pair with 15. A lot of different ways once we've figured out a couple angles here. Number 17. 17 is in the same position as 13, so those are corresponding. Again, I could have got that a couple different ways. These are vertical, these are a linear pair, these are alternate exterior, but I went the way I went. And the last one, number 11. Couple ways here. I could either do this as a linear pair. I'm going to say that it corresponds with 15. They're in the same position, so it is also 78. Remember, when we just have two lines that are parallel that are crossed by a transversal, all of our angles are going to be one of two measurements. In this case, it's 78 and 102. and we could fill out all of the rest. They're all going to be either 78 or 102. If we add some more lines in there, this isn't necessarily going to be true, and we got to think about it a little bit more. But if it's just 2 lines and a transversal, we can figure out all the angles, and there's going to be 2 measurements. All right, let's go ahead and solve for the measurement, or sorry, solve for x in this picture below. These 2 angles, because we have parallel lines, are corresponding, and they're going to be congruent to one another. So congruent means equal measurement, so these angles are equal to each other. Solve this, not too difficult of an equation. I'm going to get my x's on one side. We don't have to do this as an algebraic proof, but we could. Subtraction property of equality. Addition property of equality. When I'm adding, I get 1x, which is the same thing as just x equals 22. So that is the value of x, which is all I was asked for in this problem, but I want to be careful and make sure, read what you need to give as your final answer. It's possible that I could have needed to figure out these angles in particular or some other angle in my diagram. So in those cases, I would want to go ahead and substitute the value of x in and figure things out. So that's 66 minus 15, which is 51 degrees. So we found this is 51, and we could figure out any angle in this picture based on knowing that this one's 51 now. We didn't need to do that here, but it's worthwhile to think about that, and some questions might ask us to do that. All right. Solve for x and y. All right. Let's see here. I suppose it doesn't matter the order I solve for them. To me, it looks like y is pretty straightforward. These 2 angles are same side of the transversal. This is our transversal and our parallel lines. These are same side interior angles, so they have to be supplementary. So that is a supplementary equation. 25y minus 20 equals 180. All right, I'll state the reasons as I'm doing that, just because it's worthwhile to remember this. Right here, I'm just going to be combining like terms, so we could consider this to be simplifying. I have 33y, 2 and negative 20 make negative 18. Now I need to use the addition property of equality to add 18 to both sides. That's going to be 198. And then I need to use the division property of equality to divide both sides by 33. Quick little calculation. Getting 6. All right, 6. So y is 6. Okay, so for this problem, we solve for y. Now we need to solve for x. I only have one angle that is marked with x, so I can't. For an equation, I need another one. I need some other angle. Well, I know that this angle needs to be equal to this one down here, because those would be alternate interior. So if I can actually figure out the measurement of this angle, I could use that to write an equation for this. So that's what I'm going to do. I'm going to find the measurement of this one, which is 25 times 6 minus 20. That is 150 minus 20, which is 130 degrees. Yeah, 130 degrees. So now I know these angles are alternate interior, so they have to be congruent to one another. Pretty easy equation now. Divide by 10, division property of equality, I get x equals 13. Again, I don't need to use this value of x, but some questions may ask us to use that to find an angle. All right, clear. All right, this one looks a little more complicated. it's not labeled for us, so we'll have to do some labeling. All right, we got measure of angle 5, which is right here, 8x minus 9, and the measure of angle 3, which is 2x plus 11. And I'm supposed to find the measure of angle 1. Okay, so I do need to find a specific angle measurement at the end. All right. Here again, we have some same side interior angles, so we do know those are going to be supplementary, which means we get 8x minus 9 plus 2x plus 11 equals 180. Simplifying this a little bit, we get 10x plus 2 equals 180. Subtract 2, we get 10x equals, so subtraction property of equality, we get 178. Divide by 10, 17.8. Division property of equality, right? Dividing both sides. Okay, 17.8. I don't love that answer. Looks like I did copy everything down right though, so oh well. 17.8, yeah. So now I need to find angle 1. Angle 1 corresponds with 5, so these have to be equal. So I can just use this expression to represent this angle as well. So 8 times 17.8 minus 9. Do a little calculation here. I get that this is 133.4 degrees. So that is my angle 1 measurement. Again, don't love that answer, but that's what we got. Yep, okay. There we go. Looks like it could be 133 degrees, so it's reasonable. All right. Ooh, here we go. We got some stuff going on here. This one is a little tricky because we got to be careful about where our transversal is. And actually, so here's our parallel lines. You can see the markings on them right there. This line and this line are parallel to one another. And we have like part of a transversal. This gets confusing for people. This is kind of like part of the transversal. It could extend further, but it only exists in the interior space. This is still a transversal. It's just not the whole thing. Doesn't show the whole line kind of continuing on forever. So we still can use some of our angle relationships to help solve this. Let's see, what order do we want to do these in? We have some options here. I'm going to solve for A first. We could go about this in a few different ways, but angle A up here is on the same side of the transversal as this one, but they are both in the interior space. So these two angles have to be supplementary. Yeah, even though this transversal doesn't continue going, we still have those same side interior angles that exist because they don't depend on us extending that line at all. Pretty easy equation here. We would use the subtraction property of equality to subtract 154 from both sides, and we find that A is 26 degrees here. So that's that angle right there. I'm gonna go ahead and label it because I might make use of it to solve some other problems. All right, again, I can do this sort of in any order. I'm gonna solve for y next. So I can see here that angle A, this angle, and this angle, which is marked as 2y, are on different sides of our transversal, and they're both in the interior. So those are alternate interior angles, and so they need to be equal, congruent. So we can say that 2y has to actually be equal to 26. Again, the difficulty isn't solving these equations, it's about setting them up. Divide by 2, division property of equality, we get that y equals 13. and that this angle overall is actually 26 degrees. But y itself is equal to 13. I guess I don't need the degrees, but that's okay. Our last angle here, or our last variable that we need to solve for is x. Okay. There's a lot of temptation, I think, in this problem to view this angle as alternate interior with this one. And people are going to get that wrong because of that. They are on different sides of the transversal, and they are on the interior space. So they seem like they might be the case, but we have to pay attention to what lines are actually creating the angle. This angle is created by the transversal and this line. It's not created at all by this parallel line. If this parallel line was not there, this angle would still be here. So since it's not created by this parallel line, I can't use the alternate interior relationship because we have to have it on parallel lines, and it's not being created by that parallel line. So that temptation removed. What we can see here is we have three angles all together that make a straight line, right? This angle, A, and this angle all together make a straight line. A straight line always totals up to 180, so we can solve this way. We can say, all right, it's got to be 61 degrees plus 26 degrees plus 3x degrees is equal to 180. We don't need the degree markers in this, but I just wrote them there. And we combine some like terms, and we can solve for x. This is 87 plus 3x equals 180. Subtraction property. We're going to get that 3x equals 93. Divide by 3. We find that x is 31. So again, in this problem, we were asked to solve for the value of the variables. So we're done. This angle overall was 93 degrees, but that's what we wanted for our answer. I had a lot of steps. Nothing was super difficult, but a lot of little places that can trap you. All right. Okay, here we go. One or two more of these here. We have a proof. So we're going to be using our postulates and theorems about angles formed by parallel lines to prove that angle 7 and angle 4 are congruent. So 7 and 4. They look congruent. A lot of people have the temptation to use one of our angle relationships directly. They want to say, okay, these angles are congruent because they look like they're corresponding. Same position, bottom left, corresponding angles. Can't do that because they are on parallel lines. They are on lines A and B, which are parallel, but they do not have a common transversal. If I think about A and B as my parallel lines, the line M is the transversal that creates 7, but the line L is the transversal that creates 4. So they're not created by the same transversal line. So we cannot directly connect these angles using those theorems before. We have to use a more roundabout path. We're going to have to connect 7 to something over here or over here, and then connect those angles to 4. So we actually have a couple pathways to do this. We could connect angle 4 to 6 because they're corresponding, and then 6 to 4 because they're also corresponding. That's one way to go about it. We can also connect 7 to 1 because they're alternate interior, and then 1 to 4 because, again, they're alternate interior. So this proof could take two paths, but we have to kind of hit one of these intermediate steps along the way because these angles share a common transversal, and these angles also share a common transversal, but 4 and 7 do not. So I'm going to go ahead and use the path that I have right there. Doesn't really matter which one we do, but that's the one I'm going to do. All right, so when you do a proof, the givens are what we start with. So L is parallel to M, and A is parallel to B. These are our statements. These are our reasons. Okay, so I have my pathway drawn here. So angle 7 is congruent to angle 1 because they are alternate interior. Oops. Interior angles. This is a theorem. Remember, corresponding angles is the one that is a postulate. And then angle 1 is congruent to angle 4, again, because they are alternate interior angles. And then by the transitive property of equality, we've created a chain. 7 is congruent to 1, 1 is congruent to 4. We can say that angle 7 is congruent to angle 4. And that is the transitive property of congruence. Pretty simple. Again, because we have two sets of parallel lines, so all the lines that are parallel, we were able to connect a chain of congruence from angle 7 to angle 4, making our proof. All right, similar idea, but we're going to show supplementary this time. So a little bit different. Supplementary, remember, means that the two angles add to 180. So we're trying to show that 3 and 2 are supplementary. Now, there are usually multiple paths for these problems, so whichever pathway I take is not really the only way to do it. It's one of the ways to do it. So I'm going to start with L, the givens, and then I'll kind of talk about an option for us given. All right. Yeah, let's see. All right, so let's do this. So we know that angle 2 is congruent to 6 because those are alternate interior angles. And we know 3 and 5 are congruent because they are vertical angles. And the reason I wanted those is because now these two angles are same side interior angles, which are supplementary. So this is going to be the idea of my proof. I'm going to state that these are equal so that I can use them for a substitution whenever I want. And I'm going to use the same side interior angles to say these are supplementary, and then make a substitution. Replace 6 with 2, 3 with 5. Therefore, we'll have our conclusion that 3 and 2 are actually supplementary. Seems easy enough. Let's do that. Let's say that angle 3 is congruent to angle 5 by the vertical angles theorem. And angle 2 is congruent to angle 6 by the alternate interior angles theorem. And angle 5, measure of angle 5 plus the measure of angle 6 equals 180. They are supplementary because of the same side interior angles theorem. That's the relationship for same side interior angles. Now, technically, I should have some extra steps in here based on the definition of congruent angles that say the measure of angle 3 is equal to the measure of angle 5 so that I can replace these. I'm going to forego that for space, but technically these should be steps that I have in my proof, in a full formal proof, so that now I can replace the measurement of angle 5 with the measurement of angle 3, and the same here. So now we make our substitutions. 5 gets replaced with 3. So measure of angle 3. 2 gets replaced with 6 gets replaced with 2. So that is the substitution property of equality. And then that is the equation that means they're supplementary. So we can say that angle 3 and angle 2 are supplementary based on the definition of supplementary angles. All right, I'm gonna go ahead and stop this video here and finish the next in part 2. So see you then.